So a little bit about myself. I'm not a CEO, CFO or a director of any sort. I'm but a mere humble draftsman who loves my job and has a real passion for BIM. I've been in the drafting world for about 16, 17 years, with most of that being in the consulting world. And in the last 9 months, as Warwick said, I've been at AG Coombs, and what an amazing ride that has been. Thank you everybody at AG Coombs for your patience, and also showing me the wonderful world that is mechanical contracting. And all of the images you'll see today are from real projects that we have going at the moment in Australia, and none of the images have been digitally enhanced or modified in any way. So, to the implementation plan. Well, everyone needs an implementation plan. That's real key in this whole workflow process. And today I'm going to talk to you about the design of fabrication BIM-MEPAUS workflow and how AG Coombs have implemented this, and also how BIM-MEPAUS add-in aids the process. So with our implementation plan, we had one, which is very important, and we needed to just prove the theory because we needed to also improve productivity. The old method of throwing the consultants' hard work in the bin and redrawing from scratch really isn't sustainable in the current market. And from that, we wanted to target zero rework. And on average, it costs the company $1,000 for every mistake that requires rework on site. And that can quickly build up into a very large number. We also had to introduce new skills to the existing drafting team. This was very important because their knowledge of the shop drawing process would be invaluable in the process and also necessary for everything to be successful. And we now have 9 Network Design Suite Ultimates, which includes Navisworks Manage, Revit, and all the packages associated with that. And they're used every day, and from drafters to engineers and even site foremen. And so when I first joined 9 months ago, we had 1 standalone license, so you can see that the commitment that AG Coombs has had and the money that they've spent to get this program up and running. And to put that into perspective, we have 22 Autodesk Fabrication CAD MEP licenses nationally, and our aim really is to have a 2-to-1 ratio, so that's for every 2 shop drawers we want 1 license of Ultimate Suite, and we're nearly there. So here we see the BIM effort curve, which a lot of you are familiar with. And that's all about bringing the design completion process forward, resulting in a lower total effort and cost. So here we have a statement or a saying which I've really taken to heart, and this quote I found when doing the research for this presentation, and I think it relates to the earlier stages of BIM in our industry, and where these models were held onto so tightly and regarded as such precious IP. And the authors were reluctant to release that. And where now I think that true competitive edge is creating a model that can be passed seamlessly throughout the BIM workflow process, and that is also key. So today we're talking about the area that I've shaded in, which really is the 2 areas of the effort curve where the model transitions from the design into fabrication using the BIM-MEPAUS add-ins and workflows. So our objectives. And what were they, and what processes needed to be reviewed in order to make this workflow successful? So we wanted to utilise and leverage off the design models, which included architectural, structural, and also other services, and develop the mechanical design models and taking them through to fabrication, because it wasn't viable just to redraw their documentation. We wanted to create a constructible Revit model, preferably using BIM-MEPAUS workflow and add-ins. And we want to fully coordinate and construct in the virtual world, and that is our aim. And this is so we can identify issues and resolve them before they become expensive site problems. And that really is key. I mean, building a building in a virtual world first, so when you get to site, there are little or no issues. And we wanted to leverage the model for BIM to field, using robotic survey stations to set out penetrations, plinths, and precast anchor points, and also test new technologies such as construction sequencing, or new processes such as construction sequencing for installation strategies, coordination of trades, and also delivery to site. And then from that, we have a great Revit model. We also want to use that for estimating procurement and using the schedulings for takeoffs of pipe, duct, equipment, valves, dampers, etc. So the first phase, design into constructible Revit. So we we take the consultant's BIM-MEPAUS model. And why do we really want the BIM-MEPAUS model? Well, here we have just the standard out-of-the-box Revit run. It consists of a few VAV boxes, some bends and transitions. And here is one that's been drawn, the exact same run, converted into BIM-MEPAUS. And you can see little differences such as frames, flanges, correct transition lengths, and angles of bends. And there's the difference between the two. And so here, really, we can see that there are some issues caused when drawing out of the box, potentially with coordination. If it's something that we can't put in the spot that you intended, then that may bring up some coordination issues on site. We then do clash detection, which is the first pass, before we've done anything. And I can hear all of your consultants in the room saying, we clash detect our model, you'll find no issues, it's perfect. But consider this, since you've issued your for construction model, the architecture and structure have evolved, and really has your model been updated to suit that? Probably not. So here you'll see the structural engineer's design model, secondary steel, which we really have found to be quite problematic, and there being a lot of significant differences. And the top one is the consultant's model, and the bottom one is the actual fabrication model. So you can see there are a lot of differences in all of this steel here, just the size and the sheer increase in number. And this is what we want to coordinate with. This is what's going to be built, so we want to coordinate with that. So we put all these models, the latest models that we can get hold of, and we put them into Navisworks Manage, which is my favourite piece of software. And from there we go on to identify clashes. Here just being an obvious hydraulics pipe through a piece of ductwork, so we'd like to think that the hydraulics pipe would move. And then we issue our clash reports. And really the important step in the first phase is assigning the tasks to the appropriate and relevant parties, and that's where the communication comes into it. So we have with Navisworks Manage 2013 the addition of grid locations, which is something we had to do manually in the past, but now using the software it does that for us. And then we have the unique element ID, which we can always type back into Revit. So if the other party is finding it hard to identify this little image and the grid reference, they type in this unique element ID and it takes them directly to that element in their Revit model. And we have who it was assigned to, and also the instruction and which has been given. And if that instruction can't be taken out, or we underestimated the severity of the clash, then we hold a coordination meeting to discuss what is really the best action in this process. From there, we use the model for engineering, coordination and safety and design. So this is where the importance of the eye in BIM becomes apparent, and really up until now all we've been doing is just 3D coordination. So why is the eye important to us? Well, here you can see some design information included in the duct. I'm not quite sure if it's clear, but it has all of the elements necessary to make it a BIM model. It tells us that there are the duct properties, the elements, the equipment it's being served from, what system it is, and the one on the right is just a dummy model. So if we receive your model with all of the information in it, we're then able to alter, if we need to, your design, and we can modify the existing systems and keep the integrity of the original design still intact. And then we also use it to run checks on the existing or modified duct and pipe runs, and also ensure they meet your design criteria. And this is done with the design information using conditional formulas in schedules, which are highlighted areas of concern. So here we have just punched in, highlight all the ducts that have a velocity higher than 6 metres a second and friction greater than 1 Pascal per metre. And so there really, that's the velocity there, the duct velocity, and the yellow one being the friction. So then we can move on to, well, it's not all about clash detection. We can move on to looking at things such as maintenance, commissioning, and also safety and design. So these don't come up in clash reports, by the way, because theoretically it's not a clash. So here we're identifying maintenance issues. We've got an attenuator with a fan, and it would be a fairly expensive exercise to get access to that fan by removing all of that ductwork, even if that was possible. And with a bit of magic, we've pushed the fan off the wall, we've removed the ductwork, or rerouted the ductwork, and it's now accessible. A maintenance guy can get to it, and it can be serviced. Our commissioning team also has to be considered. Here we've got 3 POPs, roughly 1.8 metres above the ceiling. It's going to require quite a large access panel, which all of you architects love, you know, and also it's a bit of an OH&S issue getting all the way up into that ceiling void. So the second and altered run shows the POPs at a lower level where a commissioning team can get to it, and also we do model access zones inside of Revit and clash detect against those. So if we have a cable tray running below the POPs and it's going to impede any commissioning, that'll come up in a clash. And my favourite one, the lonely diffuser, only accessible by a 6-metre ladder where you're balanced on the landing halfway up a flight of stairs. That's an interesting one, and I don't even need to go and explain the problems here. So another important thing is reporting any design changes back to the design team, and really, and that's important for structural as well. So here you can see that we've coordinated this complicated area outside of a riser, and the core walls have had some allocated penetrations which we've had to modify. So giving that information back to the structural engineers, and they can then check for any issues and potentially redesign. And that really highlights the need for the design and the construction teams to align their software versions. And we then do our clash detection, our second pass, and this is done using all of the subcontractors' models, and then we hopefully come up with a beautiful scene like that, which is 0 clashes or very minimal clashes, which we can quickly modify. And from here, we have a constructible Revit model, and we also then substitute design content for manufacturer's content if it is available at the time. Then we move on to the conversion. So this bit here, really it's done in Autodesk Fabrication Fab MEP. And what we do is we export from Revit using the BIM-MEPAUS add-in, and also in that we set our design line and graphical elements, and we import into Autodesk Fabrication MEP, Fab MEP. And then we apply the AG Coombs BIM-MEPAUS duct and pipe specifications, which is also linked to our estimating and fabrication database. And about 6 months ago, we undertook our first conversion straight out of the box, and we sort of got around about 50 to 60% of that conversion success rate. And then we applied the BIM-MEPAUS add-ins and all of the templates, and now we're getting 95%, which for us is a great result. And then we substitute design content for manufacturers, again, if there's any more available. And we add our hangers, which is really important if we're using robotic survey stations. Then we save as an MAJ file. So here's an example here of just an export in Fab MEP. This actual job was quite interesting. We're using sheet metal and cool duct in single duct runs, so that really tested our exports and imports, and also setting up our services. So the next phase is being the construction to fabrication, phase 3. We do our final clash detection with hangers. That's quite important. We need to ensure that's clash-free for installation. For example, here we've got a fire pipe which is located above our duct, and you can see the hanger going straight through that. You can also see that the fire pipe is hitting the frame. Now this frame is only in existence in the beginning and the end of the runs in Revit, so it doesn't put that in the 1400mm increments or whatever your standard duct length may be. So it's little things like this that we're picking up as well. And then we export hanger points for positioning of precast hangers on the top deck. This has been very successful to date. There are roughly 1,000 duct and pipe hangers that we've put in the top deck, and around about 1,500 left to go on one particular project. And we've installed about 300 hangers from the bottom up, and we're using the Trimble device. The benefits have been well documented, and I'm sure you'll see a presentation later on this afternoon, and also go and speak to the guys out the front there. So here we've got some pipe hangers that we've put in place, and then also some duct hangers there. On that note, really, I'd like to take the opportunity to say that there needs to really have more things happen on site. We think that surveyors need to be engaged to mark up and update the reference points or your control points. Adjustment to the building program to allow access to the site for positioning. We also want to educate the site regarding these little things that are popping up all over the place that you might be tripping over or kicking out, playing football with them. And also, we want the decks need to be traffic free and clear of debris when the points are scheduled to be set out, and that's going to be as close to the reinforcement as possible. So we've got our formwork, and then we want to put that in the night before the Rio is due to go down. So we move on to detailed drawings. Now this is happening. We're detailing our drawings while the points are being positioned on the formwork to go into the slab. So we haven't really produced any official documentation, and we're already installing or getting ready to install on site by locating these hangers. So it really has brought forward the coordination program to align with the earlier phases of the construction program, so we can actually precast these anchor points into the top deck, which is the most efficient and beneficial for us. So here's a traditional AG Coombs shop drawing showing pipe and duct. Hopefully you've all seen one of those in the past. Now we issue drawings and coordinated fabrication model. So there are three models that we issue: the constructible Revit model, the federated Navisworks model, and the CAD MEP model. And then we move on to construction sequencing. So what we do, we link the building program to our installation program and simulate different installation strategies, highlight potential site installation issues, and also use it as a training tool. And from there, we use procurement using scheduling. So some of our lessons that we've learnt, I've learnt in the last 9 months, we've proven the workflow. It works. It wasn't just a theory. It actually did work. Projects need to commit to full BIM, not partial or lonely BIM. No dummy models, please. BIM-MEPAUS standards and add-ins enable workflow benefits. And also the manufacturer's content really is key. The more accurate we can get these models before they're built, the better. And real leveraging of BIM goes well beyond clash coordination. It's a fairly big part of obviously the first phase of BIM, but it goes well beyond that. And BIM execution plans are really the key. And model management and distribution is critical. There's a lot of technology out there, AConnects, Revit server. We need the construction industry to embrace these pieces of software or applications, whether it's cloud-based or not, so that we can get the models as quickly to all of the parties as possible. I've become much more knowledgeable, that's for sure. Just by talking to the 22 shop drawers. I think I learnt more in the first week than I ever have in the last 17 years. So thanks, guys. And it's a 9-month implementation plan, and it really takes perseverance. Really, Confucius once said, "You can't have nightmares if you don't sleep." So recommendations for the workflow to be successful. The BIM deliverable to there needs to be a BIM deliverable to the project construction team, preferably using the BIM-MEPAUS add-in. The BIM execution plan for a collaborative development of the design model through to construction, and supporting manufacturers' content. Really, that's a big thing at the moment. Establishment of robotic layout systems, and the program needs to be adjusted to suit the BIM-based workflow and BIM to field. And finally, communicate and understand, which is really the key to every successful team or relationship. And try not to do this via a model or via a document or even via email. I recognise there are quite a few of you in this room that I've met or worked with along the way, CAD managers, draftsmen, and I really invite these people and everyone else and urge you to contact your equivalent in the next step of the BIM process, visit their offices and understand what they are doing, because their knowledge and experience can help you and your team and vice versa. So thank you very much.